All right, buckle up, everybody, because today we're going way, way back. Like before there was even an Earth back.
To the very beginning.
We're talking about how our planet transformed from, well, basically a ball of lava to this amazing place teeming with life. And we're using Drew Rathy's YouTube video, How Was Planet Earth Born, to guide us.
Yeah, it's a fantastic resource for understanding this crazy 4.6 billion year long story.
So to start, let's try to picture this. Just a giant cloud of gas and dust just floating in space. It's mostly hydrogen and helium, the simplest elements.
Right, and this cloud, the solar nebula, it's just hanging out, minding its own business until, bam, a nearby star explodes.
A supernova.
A supernova. Like, imagine the universe's most insane fireworks show.
Whoa, that must have been loud.
Oh yeah, the shock waves from this explosion, they just ripped through space, and when they hit our solar nebula, they caused it to, well, collapse and spin.
So like a cosmic washing machine on spin cycle.
Exactly. And as this nebula spins, it starts to flatten out into a disk, kind of like when you spin pizza dough.
I see.
And right smack in the middle of this disk, the intense heat and pressure cause a protostar to ignite. Boom, we've got our sun.
So that's how a star is born.
That's how a star is born. And our sun, it's hungry.
Hungry.
Yeah, it eats up like 99.8% of all the stuff in the solar system.
Wow, it sounds like the sun went on a serious diet.
Yeah, but thankfully, that leftover 0.2% that went on to make everything else we see in our solar system, the planets, the moons, asteroids, comets. It's amazing.
It's like using all the leftovers to create a whole new feast. But so how did that little bit of leftover dust and gas actually turn into, well, planets?
Good question. It's through a process called accretion. Basically, just imagine little bits of dust bumping into each other and sticking together.
Kind of like how static cling makes your clothes stick together in the dryer.
Yeah, exactly. And over millions of years, these little particles, they grow and grow, forming bigger and bigger clumps called planetesimals.
And eventually those planetesimals smash into each other, forming protoplanets.
Right. And you know what's really cool? We can actually see evidence of this accretion happening right now in Saturn Springs. It's the same process that made Earth.
That's so cool. So we can actually witness planet formation in action.
We can. And you know those meteorites that sometimes crash to Earth? Many of them actually contain little pieces of preplanetary dust and rock called chondrules.
So it's like holding a piece of the early solar system in your hand.
Exactly. And here's another cool thing. By studying the radioactive elements inside these meteorites, scientists can figure out how old they are, like using a cosmic clock. Some of these elements are older than our solar system itself, meaning they came from an even earlier supernova.
Wow. So we've got the sun, planets starting to form, but when does Earth enter the scene?
Well, Earth's early days were kind of a wild time, to say the least. It's the Hadean Eon, which lasted from about 4.6 to 4 billion years ago. And picture this, it's like a planetary mosh pit. Asteroids and planetesimals are constantly slamming into Earth.
Oh, I bet that wasn't good for your health back then.
Not at all. Imagine rivers of molten rock flowing everywhere. The air is thick with toxic gases. The planet's basically a giant ball of molten goo.
I can only imagine the noise. It sounds more like a heavy metal concert than a planet.
It probably was, but all those collisions, they played a crucial role in shaping Earth.
Really? I thought they would have just destroyed everything.
They were definitely destructive, but they were also essential, especially for forming our oceans.
Our oceans? Wait, how did water come out of all that fire and chaos?
Remember those asteroids and comets that were smashing into Earth? Well, many of them were actually carrying ice left over from the early solar system.
So they were like giant, dirty snowballs.
Exactly. And as Earth slowly cooled, all that water vapor in the atmosphere, it condensed and fell as rain, filling up the low-lying areas that would eventually become our oceans.
So the water we drink today might have come from those ancient ice balls from space.
It's wild, right? And you know what? Some scientists think liquid water existed on Earth, even during all that early chaos.
Really? Wow. But Earth still had a long way to go, right?
Oh yeah, it was far from being a paradise. In the next stage, Earth went through a kind of makeover, a complete reorganization that set the stage for everything to come.
Ooh, a planetary makeover. I'm all ears. Tell me more.
Well, as the Hadean Eon came to an end, we move into the Archean Eon, and things start to settle down a bit. This is when Earth goes through a process called differentiation.
Differentiation. Does that mean Earth got its first gym membership?
Haha, not quite. It's where the planet's layers, the crust, the mantle, and the core, they start to form.
So Earth got organized.
Exactly. It's all thanks to gravity and density. Imagine Earth as a giant molten ball. The heavier elements like iron and nickel sink to the center, forming the core.
Like a snow globe.
Exactly. And here's a crazy fact. The temperature at Earth's core is around 6,000 degrees Celsius. That's hotter than the surface of the sun.
Whoa, that's hot. But the core's solid, right?
Yeah, it's solid because the pressure at the center of the Earth is so immense, it keeps the iron from melting.
Okay, that makes sense. So the heavy stuff makes the core, but what happens to all the lighter stuff?
The lighter stuff like silicon, oxygen, and aluminum, They rise to the surface as the heavier stuff sinks. And as they cool and solidify, they form the Earth's crust, the ground beneath our feet.
Cool. So Earth was like a giant layer cake in the oven?
Exactly. But wait, there's one crucial ingredient missing from our Earth cake. The moon.
Ah, yes, the moon. How did our celestial neighbor get into the picture?
Well, the most likely explanation is the giant impact hypothesis. Picture this. Early Earth, still a molten mess, gets slammed by a protoplanet about the size of Mars.
That sounds like something straight out of a disaster movie.
It probably looked like one. And all this debris from the impact, it gets blasted into space. Some of it falls back to Earth, but a lot of it stays in orbit.
And that debris eventually clumped together to form the moon.
You got it.
So the moon is basically a cosmic souvenir from a massive planetary crash. That's amazing.
It is, and this impact also likely tilted Earth's axis, which gave us the seasons.
Wow, talk about a life-changing event. So we've got the moon, we've got Earth with its core, mantle, and crust. What happens next in Earth's makeover?
Well, things are still pretty wild during the Archean Eon. Volcanoes are erupting everywhere, spewing out all sorts of gases into the atmosphere, like water vapor, carbon dioxide, methane, ammonia.
Sounds pretty toxic.
Oh, totally. It was an oxygen-deprived atmosphere, not a place you'd want to take a deep breath.
No thanks. But we did have oceans forming, right?
We did. As the planet cooled, that water vapor in the atmosphere condensed, forming rain that filled up the oceans even more. And these oceans, they actually started playing a big role in controlling Earth's temperature.
Kind of like how they do today.
Exactly. And, this is one of the many reasons why understanding Earth's history is so important today. It can help us address some of the environmental challenges we're facing.
That's a great point. So we've gone from a cloud of gas and dust to a molten Earth with oceans and a moon. But the big question remains, how did life actually emerge from all of this?
That's a question for the ages, and one we'll definitely tackle in our next deep dive. Stay tuned.
Welcome back, everyone. When we left off, Earth was going through some serious stuff. Molten surface, constant bombardment from space, and an atmosphere you couldn't breathe.
Yeah, it makes you appreciate what we have today.
Totally. But we did have ozone starting to form, and that's where things start to get really interesting. So how did life actually pop up out of all that chaos?
It's a big question, and it might sound a little weird, but it all starts with those volcanic eruptions we talked about. Spewing out gases like carbon dioxide, methane, ammonia.
The stuff we think of as toxic today.
Right, but for the very first life forms on Earth, those gases weren't toxic at all. They were essential.
I guess it all depends on your perspective. So we've got the ingredients, but how do those ingredients actually become life? Like, what was the spark?
That's something scientists are still trying to figure out completely. One theory is that life got started around hydrothermal vents. Those deep-sea hot springs?
Oh yeah, I've seen pictures. They're full of all kinds of crazy-looking creatures.
The life back then was much simpler, just single-celled organisms. But the basic idea is the same. They got their energy from chemicals instead of sunlight.
So like life, but not as we know it. That's kind of cool to think about. Like maybe on other planets, life is thriving in environments we wouldn't even consider.
Totally. Those early life forms, they were extremophiles, which means they loved extreme environments.
So they were tough. Okay, so we've got these single-celled extremophiles hanging out by the vents, using chemicals for energy. What's the next step? How do we get from them to everything else we see today?
That's where things take a really big turn. Over millions of years, those early life forms, they evolve and diversify, and eventually, some of them develop this amazing ability, photosynthesis.
Photosynthesis, the process that gives us oxygen.
That's the one. It's like they invented a planet-changing technology. They use sunlight to turn carbon dioxide and water into energy, and they release oxygen as a byproduct.
So it's like Earth's industrial revolution, but powered by tiny organisms instead of factories.
Haha, I like that. And as these photosynthetic organisms spread, they pump more and more oxygen into the atmosphere. And that paved the way for more complex life forms to evolve, eventually leading to us.
Wow, so those little microbes, they're the real heroes here. But you mentioned earlier that the emergence of life had a big impact on Earth's geology and oceans too. How does microscopic life change rocks and water?
You might be surprised. Some of the best evidence for early life actually comes from stromatolites.
Stromatolites.
They're layered rock formations created by communities of microorganisms.
So those tiny organisms were building their own rock houses.
It's pretty amazing. They'd trap segment layer by layer, creating these dome-shaped structures. They're like ancient microbial apartment buildings. And they're some of the most concrete evidence we have for early life.
It's amazing that something so tiny can have such a lasting impact on the planet. What about the oceans? How did life change them?
Remember how we talked about the oceans absorbing carbon dioxide from the atmosphere? Well, when photosynthetic organisms came along, they started pulling even more carbon dioxide out of the water, using it to grow and releasing oxygen. That changed the whole chemistry of the oceans.
It's like they were terraforming the oceans, making them a better place for life to flourish.
You got it. And as life in the oceans thrived, it also affected the atmosphere. It's a beautiful example of how interconnected everything is on Earth.
It's really amazing to think about. We've gone from a ball of fire to a planet teeming with life, all thanks to these incredible processes that have been going on for billions of years.
And it's still going on. Earth's story isn't over yet.
True. So stay with us for the final part of our deep dive, where we'll wrap things up and talk about what we can learn from this epic journey through Earth's history. Welcome back. We've been on a wild ride, haven't we? From a swirling cloud of dust and gas to a molten Earth, and then somehow life.
It makes you realize just how special our planet is.
Totally. It's kind of crazy to think about all the things that had to happen just right for us to even be here. Like everything had to line up perfectly.
It's mind-boggling.
I mean, we talked about that supernova that started everything, the giant impact that gave us the main, and even just the right mix of elements to form Earth in the first place. Makes you wonder if we're really alone out there in the universe.
That's a question humans have been asking forever. And while we haven't found any definitive proof of life beyond Earth yet, well, the universe is so vast, it almost seems impossible that we're the only ones.
Yeah, I get that. But even if there's life out there, the conditions for it to actually survive might be super rare. It seems like Earth just won the cosmic lottery.
It did. We got a stable star, a magnetic field to protect us, liquid water, a breathable atmosphere, and plate tectonics, which help regulate the climate and recycle nutrients.
It's a pretty amazing list.
It is. And it makes you realize how important it is to protect this planet. I mean, not just for us, but for every living thing that's evolved here over billions of years.
So what can we learn from all of this? Like, what are the big takeaways from this deep dive into Earth's history?
For me, it's how connected everything is. From tiny microbes to giant stars, every little thing plays a part in the grand scheme of things. What we do here on Earth affects the atmosphere, which affects the oceans, which affects life itself.
A giant web of life.
Exactly, and that web is super resilient, but it's also delicate. It's survived asteroid impacts, ice ages, massive volcanic eruptions, but human activity is also shaping the planet now, and we need to be careful.
It's easy to think of Earth as this unchanging thing, but it's really not. This deep dive has shown us that Earth is constantly changing and advancing.
It is. And just like life, Earth's story isn't over yet. We're still figuring things out. There are still so many mysteries to uncover.
So true. Keep exploring and keep asking questions. Thanks for joining us for this epic journey through Earth's history.